Today we're going to talk about a programming language called Scratch. This is the programming lecture. Usually there's going to be like a philosophy lecture of the week and then a programming lecture for the week. And so welcome to the programming lecture. We are going to be using a language called Scratch for a little while in this class. And to get there, you go to scratch.mit.edu. So some very smart people made this for us. It's just a website. You can put your programs in there. So it's scratch.mit.edu. And you can click Start Creating. I'll go there in a second. But that's the one. So get here if you'd like to follow along, and I highly encourage it. But then this is the Scratch programming language. It's all graphical. It's really cool. We'll talk about it soon. Okay? Let's see, what else? Before we go any further, just my advice to you in a programming lecture is to follow along as best as you can and ask tons of questions when things stop making sense. I realize that a lot of us have never programmed before. So if it's weird, it's meant to be weird, and I want to make sure it's making sense in your brain. Okay? So please ask lots of questions, and let's get started. So before we go to Scratch and start doing programs and writing them, I just want to talk about just programming in general. What is a program? So another key word you might hear a lot in computer science is algorithm, the idea of an algorithm. So let me fix my pens real quick. Boop. There we go. Much better. So an algorithm is a sequence of steps to solve a problem. And so I would consider that just like a recipe. If you've ever modified a recipe for a food before, you've essentially written a program. That's all a program is. It's just a bunch of little algorithms together to build something that you care about. All right, so I consider a program to be a recipe, and an algorithm is like a smaller recipe, let's say. Okay, so it's just a recipe, and so it shouldn't be too scary. And so here's the silly thing that I like to ask my students who haven't programmed before. Please write a program for me. So what is the algorithm to make a peanut butter and jelly sandwich? Let's say that, I don't know, I have amnesia, or I don't understand North American culture or something, like I'm an alien. I've forgotten how to make a peanut butter and jelly sandwich. Can someone tell me the algorithm to make one? Write the program for me. What would it be? You can just shout out. Yeah, bread? What do you do with the bread? Cool. And somebody else, tell me some more stuff. What are the ingredients? What are the list of things you can't answer? You've seen this before. Anybody else? Sweet, yes. It's just, if I were in your position, I'd probably say something like, you take some bread and you put some peanut butter on the bread and you put some jelly on the bread, right? This is not too hard. Yes, this is not a trick question yet. But I'm going to pretend to be a computer and follow that recipe that I just said. Okay, so that was a program I just wrote, and I'm going to pretend to be a computer following that recipe. All right, because computers are a little weird. So if you say, all right, to make peanut butter and jelly, you get some bread, and then you put some peanut butter on it, and then you put some jelly on it. Here's what I would do if I were the computer. I'd be like, all right, here's my bag of bread. I'm going to get that out. My best drawing of a 3D bag of bread. Whee! Your little slices up in there. And you said, all right, get the bread and put some peanut butter on the bread. So, all right, I'm a computer running your program. I'm going to get that peanut butter jar. I'm going to put it right on top of that bag of bread. Cool. And then you said put jelly on the bread too, so I'm going to get the jelly jar. And I'm going to put that on the bag of bread as well. And ta-da! Peanut butter and jelly. That's exactly what you wanted, right? That's what you said. That's what I did. I put peanut butter and jelly on the bread. Any problems? So it's not at all what we wanted, right? But that's what a computer would do. So computers are very smart, but they're also very, very dumb. You have to talk down to a computer, right? They follow your instructions to the letter, and there is no room for ambiguity, right? So what I'm going to teach you in this class is how to think like a computer, how to think computationally, which involves talking to a computer or thinking in a way that has a bunch of small steps that a computer can understand and that there's no ambiguity about, and then how to be very specific with what you're asking, because if there's any room for doubt, it's probably not going to happen. Probably what you want to have happen will not happen. Okay, so hopefully that colorful example reminds you as you write your programs in this class the way you have to think. All right, so you got to like break things down, break your problems down into small chunks so that the computer can understand them. So maybe a better recipe for a computer would be like, all right, get a plate out, get 2 slices of bread, put them on the plate, get a knife, and open up the peanut butter jar. Stick the knife into the peanut butter jar. Spread the peanut butter onto one of the pieces of bread. Do the same with the jelly, right? And then bring together the 2 pieces of bread with the peanut butter touching the jelly, because you could do it the other way, and that would also be wrong, right? It would be very messy. So that's kind of the way, that's kind of the level at which you need to talk to a computer. Does that make sense to us? That's a little weird. It's a new idea, but that is going to help you, I hope. So we're going to learn a programming language called Scratch. It is a graphical programming language, and so it's kind of like you stack up some Lego blocks, and that creates your program, right, from top to bottom. So like you have a little block in Scratch, and you drag it out into your program, and that does something. It's like it does some operation 1. And then you can put another block underneath it. Like you have some room, it's going to fit in just the perfect way. You can put operation 2 underneath that, and that'll do some small chunk of something. And then you can put underneath that another block that does operation 3. And the idea of Scratch, of this programming language, is that it's going to run each of these operations in order from top to bottom as you put them together like this, from top to bottom, right? So all of these things make up your program. They are your code, essentially, and they're going to execute in order. That's the terminology, execute in order. You've never heard that word before talking about programming. It's not like the program is killing somebody. It's just like it's running. So another word for execute is run. It's just going to run those blocks in order and do those things. Okay. So that's the idea. And so let's see. What do I want to do? Let's go to Scratch very quickly. So remember, it's scratch.mit.edu. Let me just show you a little bit about it. You can click close on this. But here's on the left, you have the blocks that you can drag out onto here. The middle part is your program. Like you can put them there. And then, like move 10 steps, for example. You can drag that up. And I can zoom in so that you can see it better. And then on the right is where your program will run. It will cause things to happen in this scene over here. It's like you can make little animations. It looks cute. And then, like the first thing always in your scene, you can get rid of him, but he's called the Scratch Cat. Okay, so he's a sprite. A sprite is something that can be interacted with and moved around. So you see, as I move him, like he has a name. You can change that name, like Scratch Cat. Give him a real name. You can show and hide him. Things that you can mess with. You see how as I drag him, he's got some coordinates too. We'll talk about that in a second. He's got a direction that you can mess with. Whee! And you can do that in a program as well. And so you can have him twirl in a program. You can make him bigger or smaller. He's at 100% size. You can make him at 200% size, and he can terrorize a small town or something. And so that's the Scratch Cat. He actually has some lore. There's a wiki for Scratch, and he has a whole page about it. So yeah, he's the mascot of the Scratch language. Let's see, what else? Dun dun dun. What should I say? So there's a bunch of different ideas about the Scratch Cat. Scratch Cat is non-binary, by the way, so you can use whatever pronouns you want with the Scratch Cat. And there's a whole page about him. So yeah, these little blocks, they tell you what to do. Like if you click this block, it runs that idea, and he moves 10 steps to the right in his current direction, essentially. And so you see the X get bigger by 10. Boop. 76. Boop. 86. Every time you click it, it runs the program, essentially. It runs that block. But we'll do other things later. I can right-click and delete this block, or I can just drag it back to the toolbox, and it will go away. I have a blank program now. But that's Scratch in a nutshell. You can scroll through these, drag them out, and try them. Click on them. See what they do. We'll get to all of them, essentially, in this class. But yeah, that's Scratch. And the first program I want to make for you is, they take my computer science license away if I didn't do this. But every time you learn a new programming language, you're supposed to make a program. The first program you write in it is supposed to be a program that, says back to you the phrase, hello world. You're proving that you can tell the computer to do something for you, and it gets to talk back to you and say hello. something like that. So that is the custom of computer science. And so let's find the block that's going to say something back to us. All right. So if you scroll down, anybody see it yet? Is this one. Say something for, let's say, 2 seconds. It's this one. Say hello. And if you click that, you see that the Scratch Cat gets a little quote bubble above him. And he says hello for 2 seconds, and then he stops saying it. So you can change that. You can make it like say it for 3 seconds. Say it for 1 second. That's fine. And then you can change what he says. Hello, comma, space, world, exclamation point. So there's your hello world program. Any questions about that? So that's one program. And the idea of Scratch is you can chain these things. All right? You can chain these things, these ideas of like doing a bunch of stuff at once. Like let's say, let me drag some of these out. Move 10 steps, turn 15 degrees. So if I link them together, you see how they want to be linked almost. Boop. That creates one bigger program. If I click that, he will both move 10 steps and then also do a turn of 15 degrees. So if I link them together, he's going to move 10 steps and then also turn 15 degrees. And so it's like he's rotating around a small planet or something. But that's the idea of like doing a bunch of things at once. You're going to bring them together. It's going to do this one first, move 10 steps first, and then turn right 15 degrees second. Like you can do all this at once. First he moves, then he twirls, then he says hello world. Did you watch that? It's pretty instantaneous, but that's the idea. Okay. So let me get rid of all this, because we're just trying to do a hello world program just now. Set his direction back to 90. Are there any questions about any of that? That's like our first little program. Make enough sense? So, in general, you don't just like click a block to run the program. That's a bit lazy or boring. So let me teach you some stuff. Okay. So the stuff that you can interact with, first of all, is called a sprite. Scratch Cat is a sprite. You can add more sprites. If you click that, and like there's other things that you can choose from. We'll do that later. But each sprite gets their own program. So the Scratch Cat has his program inside of him, and so like when it's say hello world for 2 seconds, it's the Scratch Cat's program because he's like selected right now. He's the one saying that. That's why. All right. Another thing that we might want is a normal way to start the program. So a better way to make the program begin is to have an event kick it off. That's the technical term. So like clicking on a block to run it, that's like good for testing, but it's cheating. It's not a real way of running a program. A standard way of starting your program is to click this green flag. So let's hook it up so that when this green flag gets clicked, it runs our program that's 1 block long. If you scroll down or click events, you have a when green flag click block. And you see how it doesn't have any hooky hooks for other things above and below or above it. It's the thing that starts something. Nothing can go above it, but plenty of things can go below it. You see that? So this is what starts the computation. So when the green flag gets clicked, it will start running all this. Boop. So now hello world. If you want to stop it early, you can click the stop sign too. Boop. But now you see how it's highlighted after I click the green flag. It's running for 2 seconds, as long as it takes to run all the blocks. If you had him saying more stuff, now it's like it takes 4 seconds to finish the program because he says hello world for 2 seconds, then hello for 2 seconds. Do you get the order kind of idea? Is that good enough? So that's kind of cool. What else? Yeah, so events start computations, so they can't have anything before them, but plenty of things after them. And then we're going to be writing long programs in this class eventually, and so something that we'd like to do is leave little notes for ourselves, the programmers. Don't like add blocks, but leave little notes for ourselves within the program. Those are called comments. It's just a note for the programmer. It's like a sticky note, and it doesn't get run, it just gets attached to your program. So if I right-click on this little block, I have an option to add a comment, and you see how it makes a little notepad for me. And I can start saying stuff like describing what I'm doing so that when I save this program and open it up a week later, I can kind of see what I was thinking. It's like says the Scratch, makes the Scratch Cat say hello world for 2 seconds. Obviously, I don't need to leave this comment, but you get the idea. Like in a more complicated program, you'd want to remind yourself what you were doing so that you can come back and change it later. So yeah, that's a little comment, and you can drag it wherever. It's kind of attached to the block that you add it to, in a sense. But that is a comment. Yeah, any questions about any of that? Because that's our first program. Not too bad, I hope. All right, so I'm going to save this so that I can give it to you later. Save. And so you could do the same if you'd like, but I'll give you these files that you can load. So I'm saving them, and then you can load saved things. Okay, that's the idea. So I'm done with this program now. I'm going to go to File, New. That's like, do you want to replace with blankness? Sure. And so I get a blank program again. Scratchcat is called Sprite1, which is silly. Let's call him Scratchcat. So there he is again. He's the one sprite in the program right now. And here's my next example. Let's make a program where the Scratchcat goes and he gets a banana from the fridge because he's hungry. And apparently, I looked this up last night actually, cats are allowed to eat bananas. They are not toxic. I don't know if they want them, but there's no issue if they eat them, unlike other things. So yeah, let's have the Scratchcat get a banana from the fridge, and we'll talk about it. Let's set it all up. So I need the Scratchcat. That's a player in this game, or I guess it's more of a show that we're putting on. And then I need to set the scene with a backdrop. So here you have choose add a sprite, and here's add a backdrop. If I click the big one, the circle one, choose a backdrop. There is a fridge somewhere here, and I will scroll down to it. I think it's just called kitchen maybe, or no, it's a refrigerator. It's legitimately called refrigerator. So cool. And then I can place the Scratchcat outside the fridge. And then there's nothing in the fridge right now, but I can put more things in it by adding a new sprite. So choose a sprite down here. If I click that, there are bananas. Boop. And so I can put them in the fridge. And then the Scratchcat can we're going to make a program that when we click the green flag, the Scratchcat will walk over, grab the bananas, and walk away with them. Okay, that's my goal. So right now, of course, the program does nothing. What we're going to do is we're going to be moving the Scratchcat. And so do you see how when you move a sprite, you got the Scratchcat and the bananas. Those are two different sprites with two different programs. They're both empty right now, though. You see how when I move them, their XY coordinates change. There's always a coordinate system underlying, and that's going to be how you program things. There's always 0 is the middle of the screen, and you can move around that. You can go to certain coordinates, right? So events. When the green flag gets clicked, I'd like the Scratchcat to, let's see, move over to the fridge and then walk away with the bananas. Okay? So let me try and get started on a little bit of that. So I'm highlighting the Scratchcat right now because every sprite has its own program. If I click the bananas and highlight them, you see how the program went away? You can have programs associated with sprites. They belong to them. So this is when the green flag gets clicked. Something's going to happen with the Scratchcat right now. And so if I go to motion, there's some cool little blocks here. There's glide a second to some coordinates. Take 1 second to glide to some coordinates. It's also really nice. You see how if I change the Scratchcat's location, this block changes, so I don't have to hard code. I want him to move here. Let's remember what this was and type it in later. No, it'll just it'll remember that for me. So cool. Maybe I want the Scratchcat to end up here. Just put him there for a second, and that's the coordinates. -170, -70. That's the place I want him to end up. Let's put him back. And so, oh, sorry, not go to, but let's glide there. Darn. -170. Well, first of all, go to there. Go back. And I want you to glide there. Whee. Cool. So let's put him outside the fridge. And when I click the green flag now, it'll take 1 second to glide over to that exact coordinate. So watch how his coordinates will change. And it'll take 1 second to do it. So boop, he walks over. And now his coordinates are exactly that. So that's the first part. So he's starting out over there. And then I have to move him back. Okay? So if I click the green flag now, he glides 1 second to that spot, but he's already at that spot. So that's a little odd. Maybe that's our first thing we need to learn. When the green flag gets clicked, we should probably reset everything because we want to replay this animation. So the Scratchcat better start his life over here, right? Because then when I click it, he can glide. So I rerun this program right now. He's already at that spot. He's not gliding anymore. There's no need. So that is a fun idea. So let's start the Scratchcat over here by just using goto rather than glide. Just this warps him to this exact coordinate when the program starts. All right, so I'll always start there, and I'll glide to this other one. Boop. Cool. And so now if I click the green flag now, he will start his life. He will warp over to the other side, to this coordinate, and then he'll glide to the other one. Whee! So that's a bit better. You see how it's resetting it for him? Any questions about that? That's a fun idea. It has a name. We'll talk about that later. And then I kind of want to have the scratch cat kind of walk away, right? Walk away with the bananas, like go back to over here. So like glide another second to this spot, let's say. And so that's what I want the scratch cat to do. Start his life over here somewhere, glide to the bananas, and then walk away with them. But this program is only affecting the scratch cat. We have to have a program for the bananas to make it follow the scratch cat. Okay? But any questions about this so far? I've got 3 things we're doing, and it's producing animation. It's resetting it at the start, too. He's like warping over to the right. So if I stop this at any point, it's always going to reset itself properly. That's the idea. Cool. So let's come up with an algorithm to make this work. I told you a little bit about it, but just like the scratch cat having to start somewhere, like he's going to walk away with these bananas and they're going to end up over here with him at the end of the program. We better also remember to warp the bananas back to the fridge when I replay this animation, rerun this program. So that's important. I'll have to start the bananas out in the fridge, and we're going to have them wait a little while to start moving because the scratch cat needs to take a while to get over there to him, to those bananas. And let's say that the scratch cat walks slowly. I think I said 2 seconds last semester, so that's why it's like that. Let's have him walk 2 seconds and 2 seconds to get away. Okay. So when should the bananas like realize that they're with the scratch cat? After 2 seconds, because that's how long it takes for the scratch cat to get over there. Okay. So the bananas better wait for 2 seconds to start moving, because that's only then is when the scratch cat gets to them and be ready to move. And then just move the banana to the same spot that the scratch cat ends up, and have them glide. Take just as long to glide there, because otherwise it'll look like they're not part of his, not with him anymore. Okay. So you have to worry about that kind of stuff as you're writing a program, but this is kind of the algorithm. All right. So let's make a program for the bananas. Boop. So now it's empty right now. So when the green flag gets clicked for the bananas, I want them to start their life in the fridge. Or actually, let me purposefully forget to do that, and I'll show you what happens. I want them to start their life in the fridge, and then I eventually want them to glide away with the scratch cat, end up over here. Boop. Just like that. So if I go back to glide over there to that spot, and let's say take 2 seconds, because that's what I did for the other one. So like if I start them here, and I run this program, this is what the scratch cat does. He takes 2 seconds to get over here, 2 seconds to get back. When I start this program, the bananas are going to immediately move to the right. So watch. Whee! They're passing the scratch cat. So that's why the bananas need to wait. They need to wait those first 2 seconds. This one is just like warp over here. That's instantaneous. This one, you got to wait 2 seconds. This is how long it takes for the scratch cat to get to the fridge. So like, maybe we should leave a note for ourselves. Like this is when the scratch cat moves to the fridge. And he takes 2 seconds to do it. Because that's how long we're gliding. See how that's a useful thing to remember now? And we'll read that when we come back. So that's why the bananas need to wait for 2 seconds. They're not ready to glide just yet. So that's how long the scratch cat takes to get over there. And there's, I think it's control. In control, it's a wait 1 second block. We can change that to 2 seconds. So this is what the bananas should do. They need to, I'll zoom out for a second, wait for the scratch cat to get to the fridge. That's important. All right, so now if I put these bananas back in the fridge, and I zoom back in, the bananas, this is the bananas program, right? This is the scratch cat's program. The bananas will wait for 2 seconds, and then they'll start gliding. Then it'll run that block, and it looks like the scratch cat's holding it. Does that make sense? So there's still that problem. If I rerun this program, try to imagine right now in your mind what's going to happen to the bananas. They stay there because I have not reset them at the start. Okay, should always do that resetting. So if this is where I want the bananas to start their life in the program, I better warp them there with a go-to block at the start. Okay, that's the starting point for those bananas. So now I think we got a program. So the scratch cat does this. Remember, he starts his life over here. So like if I ever like mess things up and like I pause the program when the scratch cat's at a weird spot, he'll always start over again in the right spot because I've started him out in those particular coordinates. So there he goes. Glides 2 seconds to there, glides 2 seconds away. All right. And then the bananas, they start their life in the fridge. They wait 2 seconds. Bananas are waiting right now. And then they run this block that takes 2 seconds to go somewhere. And so it looks like it's following the scratch cat because he's also taking 2 seconds. All right. If this was messed up, if this was like glide 1 second, it's like the bananas are moving on their own at that point, right? Because they're going to move faster. So it took 1 second to get there rather than the 2 that the scratch cat was walking with. Okay? So you kind of have to sync them up like that. But that's a good program. Are there any questions about that? Were you able to get something similar on our computers? That's kind of cute. So yeah, that's programming. You've just written some programs. So I'm going to save this, give it to you later too. Let's see here. And, oh yeah, question?
Do we need to be saving these too? Or?
Oh no, I'll give them to you. If you want them for yourself, that's totally fine. But I will give you my copies. And the code from class page, which I'm sure you've seen. I forced you to look at it. Okay? So there's that. And then, yeah, here's my last cool example of the day. It'll take us a while to get to it, but let's have an alien abduction example of the scratch cat, like in a cornfield, and like a UFO coming down, sending out its tractor beam, and sending up the scratch cat. Then he disappears, and then the UFO flies off. Okay, so poor scratch cat, but this is going to be our example. Okay, before I start, this word, this is something we've been doing. So initialization is when you start something somewhere. Something we say is initialize when you give it a starting value. And so what we did in this program is we initialize the scratch cat to start over outside the fridge. We initialize the bananas to start inside of the fridge. We gave them that initial value. Okay, so that's a word. And now let's do the alien abduction example. It'll be fun. So, okay, here is my little algorithm. Here's my game plan for us. So we're going to need, well, let's set the scene first of all. Let me make a new project. Sprite 1 becomes the scratch cat because he deserves his name. And then there's like a backdrop for a cornfield or something. There's like a farm maybe. Field maybe. Hay field. Oh yeah, perfect. And then here's the scratch cat down here. And then I need like a flying saucer or something like that. And so you could also draw your own, honestly. Like there's a plus and you can paint your own if you'd like, but I'm just going to choose one. I think there's like a rocket ship. That's the closest thing to UFO. Rocket ship. And so like let's pretend this is an alien spacecraft. And it's like going to fly down, send out its tractor beam, bring up the scratch cat, and then fly. Okay. That's the goal. And let's see here. Yeah, so those are like the pieces. So here's like the game plan. So first of all, the UFO needs to like appear because it's warping into the atmosphere or something. So like they're showing and hiding, and there are blocks to control that. So like we're gonna start off, initialize the rocket hidden, then it'll appear, then it'll move down, then it'll send out a little beam that we'll draw in just a second. Then the cat will move up, and then the cat will disappear, like he's gone inside the spaceship. Then the beam will too. And then the spaceship will fly off, and maybe it will disappear at the end too, I don't know. So yeah, that's the idea. That's where I'm going with that. So it's like the process. The UFO will appear, it'll be hidden at the start, but then it'll stop being hidden. It will move closer to the ground, so like it'll get close to the cat. It will send out a little beam, the cat will glide up into the beam, and then the beam and the cat will disappear, and then it'll fly off. Okay? That's the goal. So that's my little algorithm. Let's implement it. Let's make it happen. So let me show the cat for a second. Like, let's get everybody in their starting positions because we know to do that now. So when the green flag gets clicked for the rocket ship, maybe like this is a good spot for it, way up here. So like warp there and make sure to go there at the beginning. And then we'll do later things. And then the scratch cat, he's going to get beamed up eventually. Like at the start of the program, make him back down here. So when the green flag gets clicked for the scratch cat, this is his program right now, then I would like him to begin his life warp to here, please. Go to this exact coordinate, wherever I just put him. Okay, so I'm just initialize these things. So So let me add a comment there. So initialize. That's our new key term. Initialize the scratch cat to be at the bottom of the frame, on the ground, in the field. All right. That's my little hint for myself later. And then we need a beam. So here we go. We're going to make a sprite, but there is no beam sprite. So instead of clicking choose a sprite, I'm going to drag up here, or move my mouse up here and click paint. Boop. And then it opens up this little paint tab, and I can draw stuff. I can make a bunch of lines. So here I am making some lines. I'll just make a little, what's it called? It's a trapezoid, I don't even know. This is a beam. Okay. Close it off. And I can use the paint bucket to fill it in with a color. And let's see. So there's my little beam. And let's make it kind of see-through too. Here's my beam. There is it's in, I think, is it maybe sensing? Or it's probably looks, actually. Sorry, it's just looks. There is a not change color effect by 25, because that like changes the color around, which is kind of cool. But there's other options. There's a change ghost effect, and that's transparency, right? So change the ghost effect, or just like set the ghost effect to, let's say, 50% transparency. So if I click this, so now the beam is 50% transparent, and like I never have to do that again. That's like just look like that. Looks like a cool beam, see through. Like that's what's going to look like. Isn't that fun? So that's that. So now I have a beam, and I'll call it, instead of sprite 1, I'll call it beam. Cool. So it will have a program. Scratchcat will have a program. That's got a program. Rocketship has a program. Beam has a program. Let's just give it something. Like when the green flag gets clicked for the beam, we'll do something with it later. Okay. But like we've got a little scaffold for all of these now. So the cat starts out down here. The rocket ship starts out not there, but up there. And then the beam, I guess we want to always, I guess it resets itself every time we do that. So the beam better, let's see, better have its ghost effect set always then to 50 at the start of the program. So no matter where these things end up, Scratchcat and Rocketship, their initialization will force them in those spots. And then the beam, it'll just stay there. It's fine. All right, so that's the setup for those. So I don't think so, because the Rocketship's going to come down, send out the beam, and then Scratchcat's going to come up. The beam will go away. The beam never needs to move, I don't think. But maybe I'm going to have you try to change this program after I do it. And so you could change where the beam is. That's a good thought. So maybe think about how you might do that. Let's see here. So yeah, at the start of the program, this is what we got. But I want it to be like inconspicuous. I want the Scratchcat to be surprised that he's being abducted right now. So at the beginning of the program, sure, the rocket ship should be up here, but it should be hidden. All right. And so I guess it's looks probably. There's a show and a hide block. So at the start of the program, rocket ship, I don't even care where you are right now. Hide yourself. Hide yourself, get into position, but don't be visible. All right. Same with the beam, right? The beam should not be hidden, or should not be visible at the start of the program because it's part of the rocket ship. Does that make sense? That's the idea. So just yell at me if this ever gets confusing. But like, this is the initialization of the rocket ship. Like, get in place, but don't show yourself. It really is up here. Like if I click it and show it, it's like it's up there, but it's hidden now. That's beautiful. Beam is also hidden and transparent if I were to ever show it. Okay, does that make sense? Is it working? So, all right. So first step of this program is the UFO better appear. So it better stop being hidden. Okay, so that's the idea. So I guess I don't really need this hide. It's just like, let's see, maybe wait a second or something, but get in position and show yourself, little rocket ship. That's the idea at the start of the program. Maybe it can like wait a second. I'm not sure. That's fine. Like wait a second to show yourself, little rocket ship. So there it is. Boop. It warps into our atmosphere. And then the rocket ship should glide down to be closer to the Scratchcat because it's eventually going to send out the beam. Yeah. So after it shows itself, it should glide down to, let's say, there. Glide to, I guess, that coordinate. That's fine. And so now this is just the rocket ship's program. Starts out hidden, takes a second to show itself, and it glides down. Starts out hidden, waits a second, shows itself, glides down. Isn't that fun? And so now All right. Next step, moves close to the ground. We did that. UFO sends out a beam. So, this is the beams program now. How many seconds into the program should the beam wait to be sent out? At what point is it ready to be sent out? Not there, but then, right? Not yet, not yet, not yet. Now. How long is that? Can we calculate that from this program? It's 2 seconds. Because the beam, everything that doesn't have seconds associated with them is instantaneous as far as the program is concerned. Like this hiding, instantaneous. Go to warping, instantaneous. Wait a second. Now this program is sitting there. Take a second to do that. Show yourself instantaneous. Glide 1 second down to the spot. That's another second we just took up. So it takes 2 seconds, does that make sense, for that rocket ship to get into place. So this beam better wait 2 seconds for the rocket ship to get to the right spot. Okay? And then it can show itself. Then in looks, it can show itself. Okay? So again, wait 2 seconds. This is for wait for the rocket ship to get into position. Okay? That's why we're waiting. So we're on the beams program now. Starts out hidden, sets a ghost effect to 50, waits 2 seconds, and then it shows itself. Let me position a little bit better. That looks better. There. Like it'll be in the front. Cool. All right. So now, let's go to the beams program. Hide, become transparent, wait 2 seconds, then it sets itself and becomes visible. Does that make sense? We're waiting on the other program. Because we're running like 3 programs at once, 1 for each sprite. Does that make enough sense for the beam? Pretty cool. And then whose job is it to do something? It's the cat, right? The cat glides up. So he should glide up to here. But he's got to wait a little while, right? He's got to wait for the beam to appear before he glides up, because it's the beam that's sending him up, right? He's being beamed up. So, how long does the Scratch Cat need to sit there before he gets beamed up? My new question. Here's the beams program. He needs to wait until the beam is visible. How long until the beam is visible? 2 seconds. Good. All of these are instantaneous, but this one, the beam waits 2 seconds to become visible, because then it shows itself. So the Scratch Cat will also be waiting 2 seconds. Good. So let's see here. We got the Scratch Cat will eventually also become invisible once he gets beamed up. So let's just make sure that he shows himself at the beginning in a spot, because he will eventually become invisible after the program's over. So let's just initialize him to be shown. But he's gonna be beamed up, and we're gonna make him invisible at the end of the program. So let's just yeah. Let me just get rid of it, and I'll add it back, and I'll show you why we need it. But okay, so the Scratch Cat's waiting 2 seconds for the beam to become visible. All right. I'll add another comment to that one, right? Why not? Be over here. Wait for the beam. Cool. Alright. And then, sorry, that's kind of ugly, but who cares? And then the Scratch Cat needs to be beamed up. Like, he needs to get closer to the ship. So let's have him take a little while to do that. So we'll have him glide up to that spot in motion. Glide, I guess, take a second, why not? To that spot. Let me make all that visible. There we go. Glide 2 seconds to that thing. Alright, so now the program is this. Rocket ship comes down, waits 2 seconds. This is the Scratch Cat's program. He's waiting 2 seconds, because that's when the beam becomes visible. And then he's gliding up into the ship. And now, he should go away, right? He should be beamed up. So the Scratch Cat should disappear after he's glided up like that. So he should become hidden. And then we'll also hide the beam too. But we'll get there. So boop, down, 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 up, 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 invisible. Cool. Now if I restart this program, do we see the problem? Go. Yeah. That's why we need to initialize the Scratch Cat as shown. Yeah. So make sure he's there. Show yourself. And visible. So now, there he goes. He's always visible at the start now. Up, up, up. Bam. And we'd like the beam to go away at the same time. So, alright, here's the Scratch Cat's program. How long does it take for the Scratch Cat to hide himself? after the beam gets shown. So like, I guess in total, there's the beam, blank, boop, up he goes. So we're waiting 2 seconds for the beam to become visible. That's fine. And then the scratch cat takes 1 second after that to glide into the ship, and that's when he goes away. So it's 1 more second, right? The beam stays visible for 1 second, because that's how long it takes for the scratch cat to get up into it. Right? So this is another wait, 1 second, because that's how long it takes for the scratch cat to, oops, not duplicate, but add comment. I'll put it over here. Wait 1 second for the scratch cat to be beamed up, and then we're going to hide the beam. This is the beams program right now. Then we'll hide that beam. Okay? There it goes. Shows itself for 1 second after 2 seconds have elapsed in the program. Boop, up, and now they're both gone. Is that making sense so far? So it's a lot to think about. It's in order, right? This is computational thinking. Got to worry about all this separate stuff happening all at once. And then, after that, the rocket ship needs to fly off, right? So that needs to fly off up into the stratosphere or something. So you should glide, the rocket ship should glide up to there, let's say, and then hide itself. But, glide off and hide yourself. But there needs to be a gap, right? Because the rocket ship's coming down, then we need to wait for the scratch cat to be beamed off, right? Boop, up, and then away. Because if I connected these right now, watch. We need something in between. We need waiting. Because then it goes off, right? It needs to wait for the scratch cat to be beamed up. So how long does it take for the scratch cat to be beamed up again after the rocket ship gets into place? I think it should be 1 second. You can play around with this, but like the beam is shown when the rocket ship is in the right spot. It takes 1 second for the scratch cat to be beamed up, and then it hides itself. So I think it's 1 second after the rocket ship gets into place. Does the rocket ship is it ready to be beamed up, right? To be flying away? Whee! Yeah. Oh god, that's beautiful. Okay, so add comment. So let's say this is wait 1 second for the scratch cat to be beamed up. Beautiful. And this was 1 second for just suspense. Wait 1 second to show the rocket ship after the program starts. Whee! Comes down, beams up, flies off. Okay. I think that's the final program. We completed all our tasks. And let me try to explain each individual program for each sprite. Right? So when the green flag gets clicked for the scratch cat, he starts his life down here. He's going to show himself. He'll wait 2 seconds for the rocket ship to get into position. Then he'll glide, taking 1 second up into the rocket ship. Then he'll hide himself. Right? So that's the scratch cat. That's what he's doing. These things in that order. Okay? Cool. And that's working in tandem with these other things. So the rocket ship starts out hidden, starts out up here, and then it waits a second to show itself. All right? Waits a second to show itself, then it glides down into place. Glide 1 second. It waits a second for the scratch cat to be beamed up and to disappear, and then also the beam to disappear. And then it glides off and hides. Glides off and then hides itself. This is like it's warped away. So that's the rocket ship's program. It's doing quite a few things. And the beams program starts out hidden, of course, because the rocket ship isn't ready. It becomes transparent. It waits 2 seconds for the rocket ship to get into place. Then it shows itself. Then it waits 1 second. That just means it's showing itself for a second, right? Before it hides itself. So the beam is visible for 1 second after 2 seconds have elapsed in the program. So it shows itself after 2 seconds and stays visible for just 1 second. See how I'm interpreting that? Whee! That was pretty fun. So I think that is everything that I wanted to do for this program. Are there any questions about it? Alright, so I'm going to save this so that you can have it later. Save. And now I'm going to give you all this code, and I have a question for you. So my task for you, I'll give you plenty of time. I got plenty of time. I'll give you like 5-6 minutes. Take this example, recreate it if you haven't already. get it working. I'll come around and help you if you need any help. But maybe this time change it up. Like you can change it up in any way you want. But like here's an example. Here's an idea. Like maybe have the scratch cat get away safely. Like have him like yell obscenities at the UFO and run away and get away safely. Okay. But here's my code for the scratch cat. Oh, it takes. Let me do that. There. Here's my code for the scratch cat. Here's my code for the rocket ship. Zoom out for that one, I guess. And here is my code for the beam. So yeah, you know how to make the cat say stuff. You know how to make the cat move and run away, maybe, if you want to really do that example. But like, change this around. Do something else cool instead of exactly what I did. Okay? So take a while, just play around with Scratch, help each other, talk to your neighbors, and yeah, just take like 6 minutes to play around. Like that's how you learn. And I'll be here to help.
What are your names? Natalie? No.
Maybe you can like draw an explosion and have the scratch cat blow up. All right, another minute or so. Some cool stuff. I'm sure they're cool. You'll have plenty more time to play around, but let's come back together. I would like to, in just a few more minutes, I would like to release your first programming assignment, and then you can come back to playing around. There should be still plenty of time for that. Let's see. So, here we go. Dun, dun, dun. Did I save this? Yeah, Scratch Project 2. Cool. So, here I am in Canvas releasing your programming assignment 0. Because we start counting at 0 in computer science. Like the first thing is number 0, then it's number 1. That's really the second thing. So you'll get used to that. So this is programming assignment 0, due week 3. All right. So it will be due for most of us on the 25th. All right. So like the essays and stuff, those are usually going to be due on Tuesdays. But I'm going to make the programming assignments usually due on Thursdays. All right. So January 25th at 5 p.m. So that's that one. And then here's your programming assignment. So like I said last time, if you have taken a computer science class before or you're already a programmer for some other reason, then I have a second option for you. So don't listen to the start of this, all right? If you are new to programming, I have a programming assignment for you. And then if you've already programmed before, I have a default assignment, and then we'll talk about getting you a custom assignment if you would like one, all right? So if you are new to programming, this is your assignment. I would like you to go to hourofcode.com, and it has a bunch of little tutorials that use a Scratch-like language, if not exactly Scratch. So you can make a bunch of cool stuff, make Flappy Bird, plenty of fun things, even 3D games, in this block-like environment that looks a lot like Scratch. So just pick one of these and spend an hour and complete it. And it will, at the end, it will either tell you like everything is finished, or it will tell you, it will like give you a certificate of achievement or something, and that's what you turn in. Okay. So to get points for this, go to here, pick something, whatever activity looks most fun to you, and upload a screenshot showing me that like you got to the end or you got your certificate or whatever it is. Okay. Make sure I can see your code as well, so I know you didn't like hack the website or something to like get to the end. But that is your assignment. So go to this website, pick something, show me that you finished it. Any questions about that? That's for most of you. Those of you who have not programmed before. If you have programmed before, I have a default assignment for you if you would like to do it. I will also have you learn a completely different language. This is a fun language called Racket. It looks nothing like C++, which I assume is the language you know right now. I'd like you to read the first 2 sections of this How to Design Programs book. You click on it to get to the table of contents. Oh, no, sorry. You click on it to get here. There you go. And it's in section 1. It's chapters 1.1 and 1.2. And it will teach you this language called Racket that uses nothing but parentheses. It's going to look really, really weird. And that is going to melt your mind a little bit, and I think that would be fun. It'll also allow you to draw stuff and eventually make animations, so that's why it's kind of similar to Scratch. So please do exercise 2, and I'm sure that that is on that second chapter. So please, let's see. It's not even up here, sorry. Exercise 2, there it is in 1.2. So complete that, and then just turn in like a screenshot showing that you completed it. Okay. So that's your assignment. If you would like, you'll have to install the Racket programming language. There's an IDE called Dr. Racket, and I can help you with that if you're having trouble. But if you have programmed before, that is your assignment, okay? So that's what you'll be doing. Though, if you've programmed before and you don't, like, this sounds cool, but maybe not the coolest thing to you, then we can talk, and we can come up with a custom programming assignment that will also take you, like, the 1 hour that other students would take. Either one of those, okay? So, yeah, that is my, that's my spiel. Any questions about either of those assignments? I'll just turn in a screenshot one way or another. Okay, so that will be due then, and that is all that I have to say. So the rest of the time is all yours to continue working and ask questions, and yeah, I'll stop recording.